Assalamualaikum and very good morning to Doctor and my fellow friend. Today, my group and I will explain about the vector integral calculus. My name is Muhamad Kamil bin Nazamdin and I will explain about the question 1 of 1 Roman. This is my friend.
My name is Ahmad Kamal Mukri with metric number 182327 and I will explain for question 1 to Roman.
Okay, my name is Azamuddeen Shauqi bin Ahmad Sukeri, metric number 183766, and I will explain the last question, number 2.
Okay, for the question 1 Roman, given the region D of boundary C, we have to analyze the line integral of the equation given. This is directly by parameterizing the path C. And the solution for this question is as here. This is the equation given by the question, and this is the region which is also in the equation. From here we can know that this line is y equal to x, while this line is x equal to 1. This line is y equal to 0. This is C1, this is C2, and this is C3. For C1, y equal to x. Then we can get from that dy is equal to dx. Using line integral with lower limit x equal to 0, upper limit x equal to 1, we can get this equation by plugging in dy equal to dx. So we can eliminate either y or x. In this case, I eliminate y by plugging y equal to x into the equation. So we will get x cubed dx minus x squared dx, which will result into 0. Next, at C2, y is equal to 0. Then we will know that dy is equal to 0. Plug dy equal to 0 into the given equation, and we will get this equation. Using line integral, we integrate the equation, and then we will get this negative y cubed over 3, and then input the lower limit, which is 0 and 1, we will get negative 1 over 3. Next, at C3, x is equal to 1, so dx is equal to 0. We plug in dx equal to 0 in the given equation, we will get negative y squared dy. Using integration, y equal to 0 as the lower limit and y equal to 1 as the upper limit, we will get negative y cubed over 3. By inputting 0 and 1, we will get negative 1 over 3. So, the total value of the line integral is equal to 0 plus 1 over 4 minus 1 over 3, which is the final answer is negative 1 over 12. For question 2 Roman, we will explain by my friend.
Okay, so for question 1 to Roman, the question asks to solve the same equation by using green formula. So here is green formula. Green theorem. Green theorem. Integral p dx plus q dy equal to we have to integral delta q over delta x minus delta p over delta y dx dy. So we have to use this green theorem, we have to find first delta q over delta x and delta p over delta y. To find delta q and delta x, we have to use the equation that given in the question. We got p for px and y equal to x cubed, and for q s y equal to negative xy squared. So we have got delta q over delta x equal to negative y squared and delta p over delta y equal to 0. And then we put in the equation and we got this function, we got the negative y squared. So after that, we just put into the green theorem equation. We got this negative y squared. Here we got to integral negative y squared dx dy. So to solve this kind of question, we have to first integrate dy first. So ds first. We have to integrate ds first. So to know the limits, upper and lower limit is we have to refer from this this graph. From the graph, from the graph we know that the upper limit for and lower limit for ds is 1 and y. So we use the basic integration, integrate, and then we substitute the upper and lower limit value. After that we integrate for dy. The dy, the upper limit and lower limit dy also we have to find from this graph. And from this graph we know that the upper and lower limit for dy is 1 and 0. So same, we integrate and we put the value for upper and lower limit. And then we calculate, so we got the value negative 1/12. Which is the same with the first Roman.
Okay, for the second question, we need to use the volume integral theorems to calculate the volume of the shape. Okay, from the equation, the equation given is x square y z dz over 4. Okay, to make it this equation easy, we put the 1/4 out from the integral. Then we integrate for each plane. I mean dx, dy, and dz. Okay, firstly we integrate the z terms, which we get the result is z square over 2. Okay, next, in term of y, as we know the equation is z equal to 1 minus x minus y. Then we put this value into the equation, the equation. Then we get this equation. To make it easy, then we let it, or we use the substitute method for integration. We let u as the equal to the 1 minus x minus y. Then from here we know that the limit for y is 1 minus x and the lower limit is 0. We use the substitution method and we get 1 minus x minus u time by u square and the negative du. Then we move the negative in behind the equation, and we expand the u square into this bracket. Then we get this equation. Alright, next step is we put the 1/2 outside the bracket, and we integrate each term, and we get u cube over 3 and so on. Then we plug in the limit into the equation, and we get this equation. As we know from the previous equation, we let u equal to 1 minus x minus y. Then we substitute the y with the limit as we have put before, which is 1 minus x and 0. From here we can see that 1 minus x minus 1 minus x, the result will be 0. Also this and also this. So the whole equation will be 0. Then we minus by 0. We put 1 minus x minus y, and y is equal to 0. Then we got this equation. Okay, from that we multiply the negative value with this, and and we get this equation. Then we expand the equation into this equation. Then we move to the next step. We need to integrate each equation. As we know, 1 minus x, same as before, we need to use the substitution method. We let 1 minus x equal to u, and we manipulate it as x equal to 1 minus u. Then we integrate as usual, and we get the result as this. Since when we integrate the du over dx, we get the -1. Then this value negative, we move to the front and get the negative here. Then after that, we can expand it and integrate in term of x. Then we substitute the limit for the upper limit as 1 and the lower limit as 0. Then lastly, we get the value as 1 over 10,080. That's all. Thank you.